Today we're doing the first set of the log chapter. So x is what we are going to call the argument. Y is going to become the exponent. And b is what we call our base. So right below it in your notes you have a chart, and notice you have a log form with its equivalent exponential form. So these two forms you have to be able to go back and forth between. One thing I want you to kind of notice is that here I have this log base b of x, and over in the exponential form is b to the y. So they should always kind of be split up when you rearrange in the two forms. Notice that the base is the same in both forms, so that's a way to kind of help you remember. So for this first set, we are in exponential form, and we are going to convert this to log form. So I'll start by writing log. My base will be 10, which is right here, of 100, and it will be equal to 2. So again, you have to be able to scramble it up and put them in the right spot. Letter B, my base is 3, of 81, and it is equal to 4. So we've just converted from exponential to log. And letter C, this will be log base 4 of 256 is equal to x. The next three problems, we are in log form, and I want you to convert this to its equivalent exponential form. So again, my base is 5 raised to the second power equals 25. Letter E, my base is 2 raised to the fifth power, and it'll be equal to 32. And letter F, this one's a little bit harder because you have a variable now, will be 6 raised to the y equals 36. Go ahead and try the practice section below. So now we're going to work on evaluating. So whenever you see the word evaluate, your first step is always going to be to set the equation equal to x. And now I'm going to convert this into exponential form. So it will be 8 raised to the x power equals 32. Again, you want to have your chart from the radical chapter handy so you can rewrite these. 8 is 2 to the 3x, and 32 is 2 to the fifth power. And from the exponential chapter, we learned that if my bases are the same, we set our exponents equal. So I'm going to say 3x equals 5, divide both sides by 3, and x equals 5/3. In letter B, again, we're going to set it equal to x, convert it to exponential form. To get the same base on both sides, I'll rewrite 125 to be 5 to the third power. And now I set my exponents equal. So x equals 3. That was an easy one. Letter C, again, set this equation equal to x, convert it to exponential form. So 4 to the x power equals 32. Common base I'm going to use for both sides is 2. So the left side is 2 to the 2x. The right side is 2 to the fifth. And now I set my exponents equal, divide both sides by 2, and x equals 5/2. Moving right along. Letter D, I'll have 64 raised to the x power equals 1 over 32. Again, the common base is 2. The left side is 2 to the 6x. The right side is 2 to the negative fifth power. Because it's 1 over, that's why the exponent's negative. Now I set my exponents equal. So 6x equals negative 5. Divide both sides by 6. And x equals negative 5 over 6. Letter E, I'll have 49 raised to the x power equals 7. That's implied to be a first power there. I'm going to change 49 to be 7 to the 2x. And now 2x equals 1. Therefore, x equals 1/2. Log is always base 10 unless otherwise noted. So here when I don't see a base, that means it's implied to be 10. So this will be 10 to the x power equals negative 100. I could say 100 is 10 squared, but the problem is I still have this negative to contend with. Whenever there is a negative inside the log, my answer will always be no solution. I can never raise this side 10 to a power and get a negative 100 as an answer. Go ahead and try the next set of practice and input your answers in the video.